Okay, I'm starting the broadcast now.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. This is the second DBA Fundamentals virtual chapter meeting for January. Today's presentation is entitled Statement Execution and the Plan Cache. It's going to be presented by none other than Kimberly Tripp. I'll be turning over things to Kimberly in a minute, but I want to bring a few things to your attention first. First, I'd like to thank PASS for supporting the DBA Fundamentals chapter. The management at PASS truly work tirelessly to bring free training all over the world, and they do a great job at it. My name is Steve Cantrell, and I'm the Chapter Vice President of the DBA Fundamentals virtual chapter. In February, we're going to have Joey D'Antonio, March the 3rd, presenting a session called Virtualization 101 for SQL Servers. Later in February, we're going to have Glenn Berry presenting a presentation entitled Dr. DMV's Troubleshooting Toolkit. That's going to be February the 17th. In March, we're following up with Denny Cherry and Paul Randall on the 3rd and the 17th, respectively. This session will be recorded and will be available in our archive session within a week. We should be able to get the slides and scripts from Kimberly to put on our site. You can also get the slides and script from www.sqlskills.com. Okay, that's all the housekeeping I have right now. Today we have Kimberly Tripp presenting Statement Execution and the Plan Cache. Kimberly, for those that don't know her, is the president and founder of SQL Skills. And Kimberly's been a Microsoft SQL Server MVP and Microsoft Regional Director for over 10 years. She's an author, consultant, and a top-rated speaker, having spoken all over the world at PASS, TechEd, SQL Intersection, and numerous other events around the world. She has over 20 years of experience designing and tuning SQL Server solutions with a focus on optimizing procedural code, indexing strategies, statistics, and partitioning. When she's not tuning SQL Server, she's diving and photographing all sorts of underwater critters, such as frogfish, with her husband, Paul Randall. Today, she's going to be talking about the impact on caching and performance of different methods of statement execution. Briefly, she will also compare and contrast with stored procedures. In the end, you'll know the best way to request data so that the stable requests are cached and unstable requests are not, giving you the most optimal performance. So over to you, Kimberly.
Great. Thank you so much, Steve. So this is a topic that I really enjoy talking about. I don't think there's really any environment that I've walked into where I haven't seen problems with statement execution and plan caching. So what I'm going to do, since this is the fundamentals chapters, I'm going to walk through all the different types of statements and when they get cached, when they're not cached, and ways that you can influence that. So I'm going to blast through a couple of logistics slides very quickly, and we'll go from there. So as you mentioned, I am from SQL Skills. We have a team of renowned SQL Server experts. Many of you know us from conferences and our blogs, so I'm not going to spend a lot of time here, but I do want to mention one thing that's really important, especially for those of you listening, and that's that our online training at Pluralsight is available for you to get a code, and I'll give you some insight into that in just a couple more screenshots really quickly here. We also have an insider program. We just send one email a week or every 2 weeks, excuse me, that gives you some insight into current topics, things we're thinking about, and it includes a video as well, so you can join our insider program. In 2015, we have a bunch of in-person training events in addition to our online training, and I just thought I would mention that. We mostly hold them in central locations like Chicago, but we do have one in Bellevue, Washington, London this year, Dublin, as well as Sydney, Australia. So you can see all of that on SQL Skills /training. As far as my background, you did a great job giving some insight into that on my bio, so I'll just say that I love this stuff. I don't mind questions. Steve said he might interrupt if there's a question that somebody's asking. I don't mind that. If we get too many questions or I can't, finish all the material, then I might hold questions to the end, but I will try to make sure that I answer all of your questions. We love this stuff. We've all been doing this for a long time, and I think that's, the folks that we hire at SQL Skills just incredibly passionate about the product and what we do. So like I said, I don't mind questions at all. As far as the Pluralsight code, if you want to get a Pluralsight code, you can email Paul at SQLskills.com and put something like DBA Fundamentals Pluralsight code, and he will send you a 30-day trial code that will give you access to all 120 hours of our SQL Skills content on Pluralsight. And specifically for what we're talking about today, I have 2 courses that each are about 7 hours long. So there's about 14 hours on statement execution, plan cache bloat, stored procedures, performance tuning of stored procedures. But you'll definitely want to make sure that this foundational content makes sense before you dive into those courses. But all you have to do is email Paul and he'll send you a code. So now let me get started. First, I'm going to start by talking about the different ways that you can execute statements. I'll talk about, ad hoc statements, what they are, but I'll also compare and contrast that with other ways to request data. Some statements you're going to find can be cached, but what happens when they're cached, when they're not cached, is kind of interesting and maybe not even what you'll expect. Then I'll dive into statement auto-parameterization and what that is and why it's not really as exciting as marketing may have led us to believe. I'll talk about dynamic string execution, SP execute SQL. These are kind of all the different ways that you can make a request for data. And then I'll tie in with stored procedures, and I mentioned that in the abstract that I really wanted to make sure that you understood how stored procedures fit into this overall view of things. Then I'll compare and contrast literals, variables, and parameters and try to clear up some of the confusion there, because I think there's a lot of misunderstandings behind what happens with the different types of values that you're comparing against. And then I'll summarize this with how the plan cache is affected and how much of your memory is going to be allocated. And I'll try to bring that all together and, like I said, answer any additional technical questions you guys might have at the end if I didn't get them during. So now, as far as the different ways to execute, you can submit statements ad hoc, right? And all I mean by that is you're sitting in, let's say, Management Studio, you type in select, blah, 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 from table, where, right? Very simple statement. That's an ad hoc statement. That statement can be what we call auto-parameterized, and I'll explain some of the scenarios where that can happen in just a moment. Now, another definition that I want to make sure makes sense to you is that ad hoc statements, that's just where you type in select, can also be submitted by dynamically constructing a string and then passing that string into the execute statement. I tend to call that dynamic string execution. It's not as common, but I just want to make sure that you understand that definition. If somebody, let's say inside of a stored procedure or inside of code, has a statement that they're building dynamically that they then pass in to execute, then that statement is what I call a dynamically constructed string or dynamic string execution. What's interesting is that those 2 types of statements, ad hoc statements and dynamically constructed strings, really work exactly the same way. So I'm going to give you more insight in a moment, but you can think of those 2 for all intents and purposes as essentially working exactly the same. Now, SP execute SQL, prepared queries, and stored procedures, I'm expecting that not all of you have used all of these things. In fact, maybe not even any of those things. But all of those actually work the same way as well. So if I talk about something that's being forced into the cache, then I'm talking about a statement that's either been prepared using a client-side caching construct from ODBC or OLADB. You can use something called SQL prepare, SQL execute. These are really application side, but I'm not going to worry about those. I'm just going to worry about how they work on the server. And they're going to actually work the same way that stored procedures and SP execute SQL work. But what gets more interesting is that stored procedures can actually have statements within them that use literals, parameters, and or variables. And how those behave within a stored procedure is something that I really want to make sure makes sense. So I'm going to actually talk not only about these things individually, but I'll also start to give you some insight into how they work inside of a stored procedure. So kind of bringing this slide all together, these 2, ad hoc statements and dynamically constructed strings, work exactly the same way. These three, SP execute SQL, prepared statements, and stored procedures, work the same way, but it does get a little bit more interesting of what happens when some of these things are within a stored procedure. So I'll come back to some of those. So now, some statements can be cached for reuse. I said that ad hoc statements might be able to be cached. There's a definition behind that, which is if the statement is deemed safe. What it means to be safe is incredibly simple. I'll give you a few more definitions in just a moment, but it has to be a very, very straightforward, very simple statement. In fact, it has to be what's deemed a trivial statement. And I will be comparing and contrasting the simple mode of parameterization versus the forced mode of parameterization. And I can mention, I notice a question about optimize for ad hoc. I'll definitely touch on that a little bit later in the presentation as well. But right now, it's a great point. What I'm describing is the default behavior without the optimize for ad hoc option set, which is not on by default. Okay, so if you execute a statement, so like look at the statements that are at the bottom of this slide. Select, and it doesn't really matter what the select list is, where the member number is 12. What ends up happening is that statement, SQL looks at that statement and it says, is this statement safe? And again, I'll give you some more insight into that in a moment. But if that statement is safe, then it also looks a little bit further and says, can I take out that member number and parameterize it, and it determines that member number of 12 is a tiny int, so it creates a parameterized version of the statement that says that the first parameter at 1 is a tiny int, and then the statement is select star, or whatever the statement is, where member number equals parameter 1. That statement goes into the plan cache with a plan associated with it. And the fact that there's a plan associated with it is really only possible when it is a very safe statement. So this one might say, use the clustered index to go look up this row. So a very simple, very straightforward plan. But what's interesting about this very simple, very straightforward statement is that if you run it again with a different value, like 278, if that value is not the same data type, which it's not, this time it's a small int, then another plan will go into cache for the small int version of that statement. So this is kind of, I don't know, I think it's a little frustrating, a little bit interesting. I wish they would look up the data type of the column and associate it with that. But the long story short here is this statement is simple, this statement is safe, this statement is parameterized, this statement is put in the cache, and any subsequent execution with the same data type will use that same plan. If the data type varies, there might be 2 or 3 or 4, 5 or 6 maybe, copies of that plan in the cache. That will lead to a very, very trivial amount of what we call prepared plan cache bloat, because each of those is in the cache per type. But that's not the type of bloat that most people are talking about when they think about that optimize for ad hoc workloads option that I've already had a question on. So let me go a little bit further with these ad hoc statements. You can see that this is slide 1 of 2. So ad hoc statements and dynamic strings, because remember I said they work the same way, to be honest, are very unlikely to be safe. So let me start with that. That whole definition, a statement being safe, it will only happen when a variety of things are true. And unfortunately, one of those things, if you look at the limitations I've listed on the slide, the very first one, the from clause cannot have more than one table. Yeah, I can hear the crickets chirping too, right? The from clause cannot have more than one table. You think about that for a second, you're like, well, wait a minute. Most of my statements have more than one table. Most of my statements I write as joins. Well, then they're not safe. Your where clause cannot have an expression that's joined by or. You can't have an in clause. You can't have a subquery. And in fact, there's actually other restrictions even above and beyond these, but I always laugh because I think these in and of themselves kind of, for me, they're enough to tell me most of my statements won't be safe. But it even goes a little bit further than this. If there's anything about the variables or parameters or literals that you're putting into that statement that make that statement vary in its plan choice or would need to vary to optimize that plan choice, then those statements won't be safe either. So it is extremely restrictive. So that's what I want to start by saying, is that most of your statements won't be safe. Now, when a statement is not safe, right, or even when the statement is safe, the unparameterized statement with each of the specific literal values gets placed in the ad hoc plan cache with its plan. This can be expensive. You might think, well, how big are these plans? Plans are on an 8K boundary, so a plan is 8K, 16, 24, or more, right? They could be, for very complicated statements, even megabytes in size. So what ends up happening, you type in some statement, that statement's going to go into the ad hoc plan cache because it's not safe, it's going to go there no matter what, right? But it's going to go into the ad hoc plan cache, and then SQL's going to save that plan so that later, if somebody executes the exact same statement with the exact same values, they will get what's called an exact textual match. SQL Server will recognize that, and it won't have to regenerate the plan. It will use the plan that's there in cache already. To be honest, the way that I just described it, that sounds pretty good. I mean, the fact that they don't have to regenerate a plan sounds like a good thing. But the problem is that this is only for the exact same literals. So if you're saying select star from customers where, you know, last name is Tripp and first name is Kimberly, and then you say select star from customers where last name is Randall and first name is Paul, each one of those two statements has gone into the cache with its plan, and if nobody has another request for last name of Randall and first name of Paul, then that statement will just end up sitting in the cache and effectively waste cache because no one else is executing that exact same statement. So then if we run this over and over and over again with thousands of executions, then each one of those is starting to bloat our ad hoc plan cache. And this is where that optimize for ad hoc queries option comes into play. You can set that, and I think I do mention it later, but since I've already had the question, I just want to summarize it because we're really at a good point for summarizing it as well here. But if you turn on the server setting called optimize for ad hoc workloads, then what happens is on first execution, SQL doesn't put the plan in cache for exact textual matching. It just basically puts a query hash. So basically, let's just say the text of the statement. So it's just maybe a couple hundred bytes rather than, you know, 8K, 16K, 24K. It just basically puts that statement in the cache, and if somebody executes the exact same statement, then on the second execution, it'll put the plan in cache. So what this reduces by turning on that server option for optimize for ad hoc workloads is it reduces that initial bloat for statements that are only executed once. Okay? So now I just want to highlight this one more time. From clause cannot have more than one table. All right. Most of your statements are not going to be safe. So do not believe the marketing about auto-parameterization. In fact, I'm going to say that statement auto-parameterization is really much ado about nothing. Since most statements are not safe, then you are going to get a lot of ad hoc plan cache bloat. And the way that the parameterization is working by default is called simple parameterization. Now this slide's a little bit more advanced, but I think the reason why I really wanted to mention this is I wanted to stress for a lot of you why you don't want to turn on the option called parameterization forced. Now this option is a database level option. It's not a server option, it's a database option. And notice I kind of start by saying that this is generally not recommended. And I really want to stress that. It's very rare that I turn this option on. Now, if this option is on in your database, and you can easily check this by checking your database options and properties, then what happens is they will work much harder to force statements to go into the cache. They're going to actually make your statements basically go into cache whether they're safe or not. Now, there's still some types of statements that won't be able to be put into the cache, but if they're putting statements in the cache that shouldn't, then you can end up with worse performance problems from something that results called parameter sensitivity or parameter sniffing problems. And I'm going to tell you more about this in a moment. So let me summarize this. The database setting by default is simple. And in the simple mode, most of your statements aren't safe, which means they're being optimized and compiled for essentially each execution, which means you are paying a little bit more to compile, but you are getting, much more likely getting, much better plans. Now, if you switch to forced, then on first execution of a statement, they're going to work really hard to parameterize it and put it in the cache, whether it would have been safe or not. And the one good side is that if statements are very stable, I'm going to use the word stable here instead of safe. This is my definition. If you run a statement and you have one parameter or one, let's go back to my example of Tripp and Randall. Select from customers where last name is Tripp and first name is Kimberly. And then you run that same exact statement, but you say where last name is Randall and first name is Paul. If you execute both of those statements and you look at their plans, and you see that their plans are exactly the same, and then you try, Cahias, Jonathan, you try Stellato, Aaron, Radney, Tim, Barry, Glenn, I'm putting all the folks in my team and I'm looking up information, right? And I keep executing different values, but I keep getting the same plan, the same plan, the same plan. Then I would say that the plan for that statement is stable even across all the different values. Now, if your statements are stable, no matter what values you pass in, and you've tried a wide variety of different values, and the most important thing here, for all of your statements that you run against your database, so if all of your statements are really stable, then you could consider using forced. One of the cool tricks to be able to see from what's in cache right now, if you have plan stability, is by looking at something called query hash. This is something you can look at in the DMExec query stats, DMV. I actually talk about this quite a bit in the Pluralsight course on statement execution. That's the one that I'd really recommend some of you to look at after this course today. But you can look at what's currently in the cache. Every statement will have a query hash. You can then take of all of your query execution stats, DMExec query stats, you can aggregate by query hash, and you can get the count of their query plan hashes. And if every query hash has only one distinct query plan hash, then that tells you that all of the statements that are in cache for that database are stable, and that will allow you to consider using forced. To be honest, I'm still not a fan of using forced unless I have no control over how I'm receiving my data requests. If I can control how I'm receiving the data requests, then there's different things that I would do much more, I think, effective than switching to forced. Because even if you look at the cache and you see that a lot of your statements are stable, The problem is that everything that could possibly ever execute against that database? Because if it's not, and you turn on forced, then you could end up forcing a statement to go into cache when maybe it shouldn't, and then subsequent executions of that statement might suffer poor performance because they're being forced to use a plan that wasn't defined for them. So I want you to be really careful, maybe even go look at your databases to see if any of them are forced. It's not the default. It's not widely used, so I'm expecting that most of you won't have parameterization set to forced, so you'll be using simple. And in simple, the good news is you'll pay more compile time, which is, of course, CPU. A lot of you have more CPU headroom, though. Right? So you'll pay compile time to get a more optimal plan, and that usually does work out to be better for a lot of folks, but there's problems with it too. So again, I still have more to tell you. Those statements that are only getting used once are placed in the cache for subsequent execution. I mentioned at the very bottom, and that's for exact textual matching. And, you know, that's interesting, but it's not that useful. So that's one of the things that I usually turn off with the server setting for optimized for ad hoc workloads. Okay, so let's move away from forced because I don't really want you to consider it. If you really are thinking about it, you should check out the longer discussion that I do in the Pluralsight course on statement execution. And if you go back to the beginning of the slides, if you weren't here at the beginning, if you send email to Paul, he can give you a code. You just have to mention the DBA Fundamentals chapter. So you can definitely watch that on the Pluralsight course. So let me move on here. Dynamic strings. Okay, so we've talked about ad hoc statements, and I said that ad hoc statements were the same in behavior as a dynamically constructed string. This is a string that does not have any real information about its construct until all of the variables and the construct is built, and it's not built until runtime, until it actually executes. You can build virtually any statement, and there is a lot to be concerned with for dynamic strings. I am not going to recommend that everybody go crazy using dynamically constructed strings. There are some incredibly powerful things you can do with them, especially for administrative purposes. So I use these a lot in stored procedures that I might create for management purposes and for things I'm doing when I look at and evaluate different servers and environments. But it's not something that you do a lot in code that users execute. And the reason why is that there's really an added level of security that SQL Server adds with a dynamically constructed string. The most interesting place is when a dynamically constructed string is within a stored procedure. That stored procedure, when, let's say, I, as a database administrator, create a procedure called Procedure 1, and that procedure accesses Table 1. If that procedure accesses Table 1 with just a normal select statement that wasn't dynamically constructed, and I own the table and the procedure, then everything's fine. SQL Server essentially allows me to give access to that table through the rights of executing that stored procedure. But if there's a dynamically constructed string within a stored procedure, SQL does not automatically give rights. That dynamically constructed string will need to have what we call caller rights. Whoever executes the stored procedure will have to have the rights of the string itself, and that's meant to protect from what's called SQL injection. But there are some ways around this. I've actually written a long blog post about this, and I didn't want to spend a lot of time on this. At the end, if people have some questions on this, I can come back to this. I put that bullet at the end. There's this whole discussion about security, but I did write a blog post called Little Bobby Tables and SQL Injection, and if you just look for Little Bobby Tables Trip, it's based on an XKCD cartoon. Some of you might already be laughing. I love that cartoon. But if you look that up, it'll give you some insight into kind of how to reduce any potential using execute as with a low privileged user. But in the same vein, using execute as could get you into trouble if you give a user higher rights than they really should have. So you want to be really, really careful from a security perspective. So I'm not going to stress too much on this, but I have to mention it because I do see it, and I want you to be very careful with it if it's there. But ultimately, the good side to all of this is that when a string is built dynamically, that statement is essentially unknown until runtime, and then at runtime, that statement will be parsed, it will be optimized, it will be compiled, and it will be executed. So it actually goes through exactly the same process that every single ad hoc statement does. If that dynamically constructed string turns out to be a very trivial, very simple statement, it will be parameterized, it will be put in the cache, and it will be used and reused over and over on each subsequent execution. If it's unsafe, which generally when you're building a dynamic string, they tend to be more complicated statements. So if it's unsafe, then it gets recompiled and re-optimized for each execution. I hear people sometimes say that dynamic strings are always recompiled. That's not really true. It becomes ad hoc, and if it's not safe, then it will be recompiled for each and every execution. Textual matching can still occur, parameterization can still occur, but again, only when the statements are safe. So, and then there's all the other discussions about the power of dynamically constructed strings, that you can create very large strings, they can be incredibly complex, they can be very frustrating as well. So I just want to caution you on dynamic strings, but there are some cases where I do really like them, okay? So moving on, what about SP execute SQL? SP execute SQL is a way for you to force a statement to be cached from your request, from your application. And the thing that's really nice about this, rather than letting SQL auto-parameterize, is that SP execute statements are typed in terms of their data types explicitly. So there's no question, if you put in 12, that statement will have defined that parameter as an integer, even if the value happens to be a small int. So you won't end up with any bloat whatsoever from an SP execute executed statement. This will force the statement to go into cache. Now, this is important. Let me explain really what this means. It will force a planning cache for that statement when one is not already in the cache. So if you restart SQL Server, or there's a database or server setting that causes what we call a plan cache flush to occur, then everything gets kicked out of the database cache or the server cache, or you've restarted SQL Server, as I mentioned, then you execute the statement. There's no statement in the cache for that statement already, or no plan in the cache for that statement already. Then that particular execution will be evaluated. It will be optimized. It will be parameterized based on how you've parameterized the statement in SP execute SQL, and that statement will go into cache for every subsequent execution. The good news is that if it's a nice, stable statement, then you'll only have one version of it in the cache, and everybody will use that, which is fantastic. It reduces how much is in the cache, it reduces compile time for subsequent executions, and you've got a plan already, so you get to execution faster. So all of that is good. The problem is that I see a lot of developers here that ad hoc statements cause ad hoc plan cache bloat, and then they hear SP execute SQL doesn't cause ad hoc plan cache bloat. So they think, oh, instead of using ad hoc statements, I should switch everything over to SP execute SQL. And that is a big mistake. See, here's the problem. Ad hoc is great when the statements are not stable. SP execute SQL is great when the statements are stable. The problem is neither is great all the time. And so that's where you really have to know a little bit about what's going on with that statement in order to choose the right method for data access. Okay, so you really want to make sure that you're using SP execute SQL only when the statement produces exactly the same plan no matter what the parameter values are that are supplied. Because this bullet right here, and let me see if I can draw, I think so, this one right here, right? If you put a bad plan in cache and then everybody starts using that plan, that can be way worse than actually generating a plan for each execution. So this is probably one of the most important things I can stress, right? I really want to stress ad hoc is great when it's not stable. SP execute SQL is great when it is stable. Now, I also hear a lot of people say, oh, you shouldn't use dynamic string execution, you should use SP execute SQL instead. And that's kind of interesting because dynamically constructed strings are ad hoc statements. SP execute SQL statements are forced cached. They're forced to be in the cache. So that actually makes them very different. I do have to admit that SP execute SQL can be a little bit safer because you can't put parameters anywhere, whereas a dynamically constructed string allows parameters virtually anywhere. So they are not the same, I guess, is really the thing I want to stress. And there are some cases where I have used dynamic strings, but in general, I tend to use more SP execute SQL than dynamic strings. Okay, so I just want to stress that they're not the same. Okay, dynamic strings are definitely a better way of handling some situations, but SP execute SQL is really best when a statement is stable. So there is a question that says, wouldn't it still be safer from a SQL injection standpoint to use SP execute SQL with option recompile? And the answer is absolutely. And I do have a more complicated scenario of this in my past presentation that I did for PASS 2014, and you guys can get to that online. So you can find that on the PASS site. And you know what? I'm keeping track of a couple of the things that I'm referencing, like my Little Bobby Tables blog post, and I will put together a set of resources, including my PASS presentation, because that one is available without the recording. It was on part of PASS TV, which is why it's available to you. So I'll make sure that that link is there too. And that was from Aaron. Hi, Aaron. All right, so anyway, moving on. Stored procedures, to compare and contrast this, work exactly like SP execute SQL. So I just mentioned that on first execution for SP execute SQL, SQL will evaluate the different values you're supplying, come up with a plan, put that plan into cache, and then subsequent executions will use that plan. Now for SP execute SQL, you might have a variety of different statements being generated. So each statement, so if there's things in your code that change the way the statement looks, change the way the where clause looks, change which columns are being requested, then each version of that statement will go into cache on first execution. So you might have lots of different statements in the cache using SP execute SQL, but for each one of those statements, the plan will go into cache based on the first execution. And if the parameters don't change what is the optimal plan, this is fantastic, right? You're going to save time in CPU, you're going to save time in compilation. But if there's different parameters going in for that statement that make, let's say, the number of rows it returns wildly vary, then this can be a horribly bad idea. And I really want you to consider not using SP execute SQL for anything that's unstable or has wildly different plans when different values are supplied. Now, literals, variables, and parameters. I want to define these things to make sure that these make sense to you. If I say select blah, 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 where member number equals 12, that's a literal. Member number is being compared to a specific defined value. Literals are what we call known values. At the time the statement, or even a literal that's on a statement within a stored procedure, literals are known values. So at the time of optimization and compilation, SQL Server will come up with an optimal plan for that statement. Okay, so literals can be what we call sniffed. They can be evaluated. We can look at what's called the histogram. This is something in the statistics that tells us good information, well, as good as it can get, right, about how many rows match this criteria. I'm really oversimplifying statistics here, but that's the idea behind it. When a literal is there, we get really the best information from an optimization perspective. Now that is true whether it's in an ad hoc statement, whether it's in an SP execute SQL statement, whether or not it's in a stored procedure. Now if you have a variable, now if we're talking about just in a query window, you say declare at member number is an integer and we're going to set it to 12, and then you say select where member number equals at MNO. Now you're using in that select statement a variable. Member number is being defined and it's being set in that declaration, in the declare line. But the unfortunate thing is that declaration is not actually executed until we execute that line of code. And what's interesting is SQL Server optimizes and compiles the batch before it executes. So unfortunately, a variable is deemed unknown at the time of optimization. So what happens is SQL looks at select blah, 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 where member number equals, I don't know. I don't know what the value is. So what they have to do is they have to get a rough approximation of how many rows might match. And now depending on what the criteria is, if it's equality, if it's greater than, if it's less than, all of these things influence how they come up with their estimate. But most importantly, the value 12 is unknown here, so they go to something called the density vector. This is the average number of rows that match for member number. So if your data is not relatively evenly distributed, then how SQL optimizes with this unknown value might not be optimal. If your data is reasonably evenly distributed, this might work pretty well for you. In fact, I've seen some people, hide a parameter by using a variable inside of their code, and they get better performance, and then they kind of think, oh, I solved it by using this variable. Well, what they've really done is they've hidden the actual value and told SQL Server to use an average, and since their data is relatively evenly distributed, it works. But in cases where your data is not evenly distributed, where the number of rows that match a member number are not, always a couple, depending on what the table is, right? If this is the member table, it might only be one. But if this is the sales table, the number of sales per customer might wildly vary, right? And as a result, using the average might be good for a lot of rows, but it might not be good for quite a few member numbers, and that's where we might not want to use this. So this one's tough. There can be some benefits to using this, but I would say there's other ways that you can handle this as well. Now, whoops, I meant to click here. Hold on. Technical difficulty. Luckily, you're not seeing it. Okay. So parameters, to finish off the definitions, they look like variables, right? But they're not variables. They're not declared with a declare statement. They're declared with the procedure's definition. And you can see here, create procedure, procedure name, at parameter 1 is an integer. That is a parameter, well named there, parameter 1. And then in my code, I also have a variable being declared. So the first select where member number equals at MNO, that is a variable. That's going to be treated as an unknown value. That statement will be optimized using averages. Select where member number equals parameter 1. That parameter will be known at the time of execution. So SQL Server will look at that value. It will do what's called sniff that value, so it'll evaluate that value, go to the histogram, figure out how many rows match, and come up with an optimal plan tied to that specific parameter. Now here's the good news. That first execution is great. Subsequent executions, if they don't look like that in terms of their optimal plan, they might actually suffer. So this is why you have to be careful, and you have to do thorough testing of your stored procedures to make sure you choose the right way to write your code. And I would take this a lot further by saying there are a lot of more optimal ways to do this. But I did just get a question asking, is select where member number equals a variable at MNO, is that the same as doing the option optimize for unknown? And the answer is 100% identical. Yes, they are the same. So you can either kind of mask a value by hiding it in a variable, or you could get rid of using that altogether, and you could just tack on option optimized for unknown on the select statement. Option optimized for unknown was added in SQL 2008. So any of you on any versions earlier than 2008 will have to use the variable trick, and that still works. So, you know, that code will still work moving forward to kind of obfuscate that value from optimization by using a variable. So yes, they are identical. Okay. Now, the life of a plan in the plan cache. So SQL generates a plan when there isn't a plan in the cache. And I mentioned that anything that you do, like restarting SQL Server, some database options, some even procedure level options, will end up clearing a plan or even a lot of plans from the cache. In fact, I was quite surprised by a few of these things. There are actually some settings that make sense. Like if you change memory, any of the memory settings, it will actually flush your entire plan cache. And I think that's a little bit interesting. I was actually surprised when spconfigure max server memory. If you change your server's max server memory, it flushes your entire plan cache. So my point is there are things other than a restart which could cause a plan to get kicked out of cache or forced out of cache, right? SP recompile is the obvious one, and a lot of us will use this if we suspect a performance problem with a stored procedure. What I might end up doing if I have poor performance with a stored procedure, I might say SP recompile procedure name, so I kick that plan out of cache, I then run it again, and maybe I get a better plan. The problem, though, is if somebody else runs it in between you recompiling and running it. So let's say it's a test environment, and this is a great way of testing different plans. I can basically execute, and then I can recompile and execute it, recompile and execute it. Well, to be honest, there's even a better way. If you don't already know of this, execute procedure name with your parameters, and then you tack on with recompile. And if you do execute with recompile, you'll end up, from a testing perspective, seeing if all of your plans are the same. And in fact, I do quite a bit of that in the procedure course on Pluralsight. So for those of you doing a lot of procedures, you might want to check that out. But those are ways to kick things out of cache, like force them out of cache. But there's even other things that might push a plan out of cache. You know, a few that catch sometimes people off guard. Statistics updates. Now this is weird because it doesn't always happen, and it actually is a little complicated. But in a lot of cases, I will say, if you update stats, what actually happens for all of the plans that access the object whose stats you're updating, they will get invalidated, which means that the plan will no longer be valid. So on the next execution, SQL will generate a new plan in cache. This is slightly different than evicting the plan from the cache because there are things that you can still monitor and evaluate from memory. So this slide is a little bit advanced. I just wanted to mention that there are a lot more than just restarting your server that can kick a plan out of the cache, and sometimes it's actually desirable. Sometimes I'll do this a lot in testing with things like SP recompile. That's a great way if you're having performance problems, kick it out of cache, and if the performance problems, quote unquote, go away, what that probably means is that stored procedure has a parameter sensitivity or parameter sniffing problem, and you'll probably want to reevaluate how that stored procedure is written to reduce those problems. And that's something that I spend quite a bit of time on in my past presentation as well as the Pluralsight courses. So there's a lot more information available on that. Now, how much of your cache, right, can be allocated to the plan cache or procedure cache? The reason why a lot of us stress not wasting memory is because memory is something you don't have an infinite amount of. But what's even more interesting is the way that SQL Server kind of divvies up that memory. And based on how much memory SQL has allocated, SQL can grow an area of the memory as what's called the plan cache. And even if right now, let's say you're not using much plan cache, but you have a lot of data in memory, SQL can essentially steal from data pages to give that to the plan cache up until the plan cache reaches essentially a maximum size. And that might sound like a good thing because plans are more expensive than getting data in the cache, because a data lookup is pretty cheap, but a plan takes more work on SQL Server's part to figure out what it should do and then put that plan in cache. So that's why they will take away from data pages for plan cache pages. But what's interesting is the amount of cache that can end up being allocated. And if you look at SQL 2005 SP2 and higher, since the math hasn't changed since then, and you look at, let's say, a 16 gig box, 4.2 gig of your memory can go to plan cache, which to me is a huge amount of memory. And really, you might think, well, who's running on a 16 gig box these days? I'm not. I'm running on 128, 256. Yes, but how many of you are doing a lot of consolidation, right? You are actually doing more and more smaller memory implementations on big memory boxes when you're using virtualized servers. And I see this more and more when people are using 1632 and they're kind of isolating an application. Maybe it's not, the most critical application, and they've decided to virtualize it, dedicate it, and then they think, the amount of data and memory that we need is X. So they end up limiting it to 16 or 32. Well, 25, maybe 20 to 25% of your memory can essentially go to plan cache, and that could cause you a lot of grief if what's in the plan cache is mostly single-use plans that's not getting used more than once. So this is why a lot of us recommend the optimize for ad hoc workloads setting, because what you can do is not have the plan go into cache on first execution, but just the statement. Now, that doesn't change these values. What I do additionally is I also go and periodically look at how much of my cache is being used by single-use plans, and when it gets to, I usually on a small memory situation like 16 or 32 gig, when I get more than a gig, I will usually clear my plan cache. So there are some easy ways to do this. I could do a DBCC free proc cache, but that clears all of the plan cache for your entire server, so I wouldn't recommend that. There's a DBCC free proc in DB, which is more isolated, but it clears all of the plans, even stored procedures. And there's a better way to do this called DBCC free system cache, and I've blogged code to help you do this using DBCC-free system cache. So I'll make sure that that blog post is in my list of links. But what I do is I have code that wakes up, and you might have that code run through the agent every 30 minutes, and at 30 minutes it might check the cache, and if more than, and you can set this, if more than a gig or more than 2 gig of memory is being allocated to single-use plan cache bloat, then clear all of the ad hoc and prepared plans, but it won't clear the stored procedures, and that's using DBCC-free system cache. And like I said, I've got that in the blog post, and I'll point you guys to that. So bringing everything together here, if a statement's optimal execution plan wildly varies, then just make that statement an ad hoc statement. I personally still prefer using stored procedures, even if it wildly varies, because I've got options with the way that I code that stored procedure to control it, because even when it wildly varies, there still might be certain patterns. If it runs 10,000 times and there's 100 different versions of it, what if one version is run, 90% of the time? If I know some of those patterns, I can probably control that a little bit better. Instead of having it recompile for every execution, I might have it only recompile for some executions. So that's where I really like stored procedures, is I know my data. I'm kind of a back-end server database person, so I use stored procedures because I know my data and I know the best way to control them. Now, if a statement produces a single stable plan, regardless of parameter values, that's where SPExecute SQL is great. Now, SPExecute SQL should just be used normally if you have stable plans. You can use SPExecute SQL and then pass in option recompile when the plans are unstable, but then you're going to have some logic and some code for knowing when it's stable versus when it's not. And in my opinion, that's less likely to be in the application layer and known by application developers. For me, I tend to use that in my stored procedures. And in fact, I actually do exactly that in my stored procedures. I will often figure out programmatically when a combination of parameters is stable, and I learned that through testing, and if it's stable, I just execute it through SPExecute SQL normally, but when it's unstable, I tack on option recompile to the statement before I pass it to SPExecute SQL. But again, to me, this is something that is done at the back end for the server developers. This is what I spent my past presentation essentially walking you through. So you'll definitely want to look at that. I've got a blog post and the past presentation that explain that in more detail. So for me personally, I don't like a lot of ad hoc statements. I think that they are a way to end up with plan cache bloat. They are a way to end up eating up more and more and more CPU. And I don't think it allows you all the benefits that you have with centralized reusable code that sits in the server that's compiled and cached for stable executions and then only not cached for the unstable executions. So for me, I use a lot of stored procedures. That tends to be my primary focus. So I knew I was going to be right about an hour here. I do have a couple of scripts that I was going to show you guys. They mostly focus on the statements, not the stored procedures. So why don't I open it up for a couple of minutes on questions. You can go through the script on your own. It uses a sample database, which I'm going to give you the link to as well. It's pretty straightforward and well commented. But let me see if I've got any questions. Yeah, I've got one comment that mentions that they should get their developers to study this. Yeah, I know this is our DBA fundamentals. This, to me, the reason I tell DBAs this is because we end up being the ones that have the problem. We have plan cache bloat. We have statements that are unstable, that are, getting forced into cache, so we have parameter sniffing problems, and we find that when we clear the cache, things improve, but only for a while, you know, and we see all these weird behaviors, or maybe we keep blaming problems on updating stats, or on statistics, I should say. Like, we have a stored procedure, it doesn't perform well, and as a DBA, we go and we update stats, and then we see that the problem's quote-unquote solved. Well, I just mentioned a couple slides ago that when you update stats, one of the side effects in most environments is that it's going to update stats, or sorry, it's going to invalidate the plans that access that object. So what ends up happening is by executing update stats, you've gone through the work of updating the stats, and maybe the stats didn't even change, but the side effect also invalidated the plans associated with that stored procedure, so SQL Server then has to recompile on the next execution. And you were getting bad performance, but now you execute and you get good performance because you're getting a plan just for you. So you're getting kind of this false positive with updating of stats. So for DBAs to really know what's going on here is fantastic, but you're right. You really want to turn around and go to your developers and show them the benefits and power of using stored procedures and not doing everything through ad hoc. I know they love ad hoc and they really want to use ad hoc for rapid application development and design, but the end result is that doesn't always perform well. So I think I hear Steve coming on.
I'm on, but go ahead and keep answering questions if you want to for a few minutes.
Okay, I was wondering if you were coming on to ask something specifically.
No.
Okay. Someone was asking if max degree of parallelism changes, flush the cache. I have the entire list in one of my other courses, but I can tell you one thing that's really cool. If you test the SP configure setting on a development server that's the same service level and the same service pack, as long as you're over a higher service pack than SQL 2005 SP2, when you run the SP configure option, if it flushes the cache, 3 messages will be written to the error log stating that the objects were cleared from the cache. So the best thing I can tell you, because it does vary version to version and even sometimes service pack to service pack, go and test it in a development environment, see if those messages were written to the error log, and then you'll know for sure when you go to, you know, that service pack, that version in production, whether or not it's going to clear your entire cache. Okay, so I got that one. So update stats is not a blocking operation, so that's kind of an interesting question, but it's not going to be the case. Update stats is not going to cause you blocking. Yeah, and the comment here, I feel like this has implications for ORMs. Absolutely. That's exactly what I am saying, is you have to be really careful with environments that are generating all of the statements ad hoc. At a minimum, you want to have optimized for ad hoc workload set, and I would also be checking the cache such that when it gets above 1 or 2 gig, even 4 gig if you're on a large memory situation, like 512 gig of memory, at about 4 gig I would still clear the plan cache to get rid of all those single-use statements from bloating the cache and wasting, you know, up to, on 512 gig, 30 gig of memory with single-use plans. So yeah, it's definitely something that we see more and more with ORMs. Okay. I've gotten most of these. Jeremy, you're saying that update stats is getting blocked by SP execute SQL, not that update stats is blocking. Update stats is not a blocking statement. That's what I said. But you're seeing update stats being blocked? Sure. That's going to happen during that recompile, but that should still be relatively short. We can maybe take that offline, but yes, update stats can be blocked, but update stats is not a blocking statement. That's what I was saying. There's a statement here, do statements that are really long hurt your plan cache, or would it be better to break them up in smaller statements? That's a tough one. I mean, I'm not going to give you an absolute, I'm not going to answer it depends either. I mean, it does, but what I would say is the only thing you're going to be able to do is test it. I would argue that the longer and more complicated the statement is, if it's just a single statement, that's not a problem. But if it's a really large monolithic stored procedure that really should have branching and conditional logic, sometimes that conditional logic and branching is best served in sub-procedures, not in a single monolithic stored procedure. And I do cover that quite a bit in my stored procedures course on Pluralsight. So is it a good idea to schedule clearing the plan cache during a slow period? To be honest, I actually check the plan cache every 15, 30, 45, 60 minutes, and I'll clear it if it meets my criteria. And like I said, if it's a small memory situation of 16 or 32 gig, I'll usually clear it at 1 gig. Now, is it a problem to clear the plan cache every 15 or 30 minutes? Remember, I'm not clearing stored procedures. I'm using DBCC free system cache with SQL plans, and again, that's in my blog post that shows you how to do this. So it's not clearing things like stored procedures, but it does clear a prepared plan, so that means that that would have to generate a new plan every 15 minutes, every 30 minutes. So you're only going to have an issue if you have a lot of prepared plans and not single-use plans, but that's what you're going to be testing in the cache. When you have more than X amount of memory in single-use plans, then clear the cache. So you can change that logic where you can only do it if it's more than X of single-use plans but less than Y of prepared plans. You'd have to add that logic, but it's easy enough to do. But yes, you'd have a small amount of extra CPU required on that mark for any statement that is getting used more than once. For the ones that are getting used only once, you'd have the same behavior. Yeah, okay, a couple people are saying that they're going to set this up. Yeah, let me know. I always love hearing from you guys when you set these things up. So there's one comment that says, are there any disadvantages to the optimize for ad hoc workloads setting? To be honest, yes, but not if you do both of the things that I'm saying. If you set optimize for ad hoc workloads, then you're putting what are called plan stubs into cache. These are pretty small. And unfortunately, finding to see if the stub is there can actually start to be expensive if there's a lot of them in the cache. So I don't want that amount of cache to get really large. So if you're clearing the plan cache, the ad hoc and prepared plans using DBCC free system cache every 15, 30, let's say every 30 minutes, every 60 minutes, then no, optimize for ad hoc workloads won't become a negative. But I have seen some people complain about the performance when SQL Server's looking in the cache to see if the plan is there because they've allowed their ad hoc plan cache to get really large. So if you do both, optimize for ad hoc workloads, and you clear the plan cache when it gets to be 1 gig on smaller situations, 2 gig in the, let's say, 32 or 64 gig, 128, and 4 gig in the 512 gig, you kind of play with it there. You might be checking every 30 minutes, but it might not be clearing every 30 minutes. And the check is incredibly cheap, so don't worry about the check, okay? So does all of this plan cache clearing criteria apply to 2012 and 2014? Absolutely. It really, as of 2005 SP2, the numbers and the amount of plan cache pretty much stabilized. So yeah, and the definition of safe and unsafe. About the only difference between 2005 and 2008 was the additional option level recompile options that you have. So a SQL statement can have option, optimize, I can't even say it. Option, the option is called optimize recompile or option recompile. So recompile has been there since 2005. Optimize for, which is where you're setting a value, that's been there since 2005. Optimize for unknown was added in 2008. But pretty much everything else stays the same up until 2014. I think that's pretty good. I might go back through here and see if there's anything else that I didn't touch on. I got most of these, I think, at some point.
I'll send you the script, or I'll send you the questions in case you missed anything, and that way you can deal with it on your blog at SQL Skills.
Okay, that's great. Yeah, thank you very much. Well, thanks, everybody. Thank you for staying. I see there's still a few hundred of you there, so have a great Tuesday or Wednesday, depending on where you are.
Thank you for such a wonderful presentation. The winner of the Amazon gift card was Lisa Herbert, and next month we'll have, on February the 3rd, Virtualization 101 for SQL Servers with Joe D'Antuna. So be with us then, and thanks again, Kim.
Great. Thank you.